Hello, welcome back to our discussion of triangles. It is day 2, let's say, because this is our second adventure into triangles. All right, so last time we talked about the different types of triangles and how we name them by how long their sides are, and we also name them by how big their angles are. And today I want to dig a little bit deeper into triangles and look specifically at isosceles triangles. So isosceles triangles are the ones where there are two sides that are exactly the same. So in this triangle here we see the tick marks. That tells us that these two sides are equal. All right, so if you would, grab yourself some crayons, pens, colored pencils, whatever you have. And I want you to take this triangle and highlight the three sides in 3 different colors. So you can color them, you can highlight them, whatever you want to do, but find a way to distinguish the 3 sides. If you don't have colors, you could do marks on them. Like you could put X's all along this side and circles all along this side and like a squiggle on this side or something. But find a way to mark the 3 different sides in 3 different ways. Okay, so I am going to, because I have my little highlighter tool here, I am going to highlight the 3 sides of this triangle in 3 different colors. I'm going to make a green side. I'm probably going to wish I had just made marks. A green side. All right, I'm going to try one more time to not embarrass myself with this. Okay. All right, I'm making a green side. All right, I got better in the end there. I'm going to make a purple side. And I'm going to make a blue side. Okay. Now, I had to make the 3 sides 3 different colors because we want to look at the parts of this triangle. So every triangle we know has 3 sides and 3 angles. It is, after all, a triangle. Triangle. 3 angles. Okay, and we know since Sesame Street the triangles have 3 sides. What we didn't learn on Sesame Street is that the sides and the angles are related to one another. They have a relationship. Okay, so what we're looking for in geometry in order to find these special relationships are what we call the opposite sides and the opposite angles. Now, if I gave you like a square or something, it would be easy to say, oh, well, these 2 sides are opposite from each other and these 2 sides are opposite. And that's not really the case with a triangle, right? The sides all come together. But what we're looking for here is an angle that's opposite to a side and a side that's opposite to an angle. Okay. What I mean by that is this. If I come down here to this angle right here, you see how this angle right here that I'm coloring blue is made by the green and purple sides. Okay. So I have a blue side. But the blue side is not involved at all in creating this blue angle. This angle was created by the green and the purple sides. This blue angle right here is opposite to the blue side. Kind of by opposite, we almost mean like across from. Right? So blue side over here, if you go across the triangle from the blue side, there's your blue angle. But the easiest way to find it is to find the angle that doesn't touch the side, right? So there's 2 angles that touch this blue side, this one and this one. The angle that's opposite to it doesn't touch it. It's on the other side of the triangle. Okay. So if I want to find the angle that is opposite to my green side, I'm going to go to my green side and say, okay, well, I don't want this angle because it touches the green side. And I don't want this angle because it touches the green side. The angle that's opposite is going to be across the way. Right? So there's the angle that is opposite my green side. My pen doesn't want to work. Okay. Oh. All I had to do was give up. Okay. Let that be a lesson to me. Oh boy. Okay. I'm just going to wait patiently for my computer to catch up. There we go. Okay. Well, last but not least, I had a purple side. Again, here's my purple side. You might already know which angle we're going for. It's the only one left. Here's my purple side. Again, I don't want the angle that's touching the purple side. So I don't want this angle and I don't want this angle. The angle I want is across the way. So as soon as my pen decides to work, you're going to see this colored in right up there. So we're labeling these opposite angles because, again, what we're looking for is relationships. And I'm going to... And I want to talk to you today about specifically what those relationships are. Oh my goodness. Okay, see, colored in. There it is. All right, so again, 3 sides, each side has an angle opposite. And if you think about it as 3 angles, then each angle has a side opposite from it. And those are the pairs, right? Those are the pairs we're going to be interested in. All right, so we're going to take a look specifically at isosceles and also equilateral triangles. Okay, so the first thing we need to do is talk about the parts of an isosceles triangle so that we can talk about them easily. Okay. When you look at an isosceles triangle, we know that we have 2 sides that are the same. Okay. In geometry, just specifically in isosceles triangles, the 2 sides that are the same, we call those the legs. We say that the triangle has 2 legs, and those happen to be the 2 that are the same. It doesn't necessarily mean they're the 2 that like the triangle is standing on. It just means that they're the 2 that are the same length. It could be any of the 3 sides. Okay. The third side, the side that isn't the leg, we call the base. And I say this because the word base, at least to me, and I've noticed over the years to kids, kind of makes us think that's the side on the bottom because it's the base, it's the bottom. It's not what it means in math, right? Base is a very specific word in math, and it means the side that isn't the legs. So in an isosceles triangle, you have 2 sides that match. Those are the legs. I like to remember it because these little tick marks look like L's, and L stands for leg. And then the third side that isn't a leg is the base. Okay, so because this is the base, these 2 angles that sit on it or touch it, right, this angle and this angle, we call those the base angles. Right there. All right, now, this says here, and it is called this, but nobody ever actually, I never use this word. This other angle up here, they call it the vertex angle. So they say, well, this is where the 2 legs come together, and this is technically called the vertex, but I have to tell you, it's not a very popular thing to say. All right, we do talk about the base angles a lot in triangles. So here's the thing about isosceles triangles that's a little bit magical. Okay, there's a lot of words at the bottom of this screen here, right? But we're going to simplify it a little bit. We know that isosceles triangles have 2 congruent sides. And as it turns out, when the 2 sides match, magic happens, and the 2 angles that go with those sides, the pairs, those are also the same. So if you look at an isosceles triangle, by definition, an isosceles triangle has 2 congruent sides. But it then follows that those opposite angles, the base angles, are also congruent. So if somebody tells you that a triangle is isosceles, they're actually giving you 2 pieces of information. They're saying directly that there's 2 sides that match. The legs match, but they're also secretly saying that the base angles match. In other words, the 2 angles across from the sides that match, they match too. Okay, so of course geometry has to make everything seem fancy, so we call this idea that if the legs match, the angles match, the isosceles triangle theorem. Okay? And it says if 2 sides of a triangle are congruent, then the angle opposite those sides are congruent. Okay, so if the sides are congruent, so are the angles across from them, period. And it works the other way too. If you know that angles are congruent, then you can say, hey, wait a minute, There's only one triangle like this. There's only one triangle that has two angles that are the same, and I know his name. His name is Isosceles, and he has two sides that are the same. Okay. So if you know it's isosceles, then you can say, okay, look, these angles are congruent. But if they tell you the angles are congruent, you can also work backwards and say, it must be isosceles. Works both ways. We call that the converse of the isosceles theorem. Anytime you can go from here to here, we call that the theorem. And then if you can work backwards, we call that the converse. And then in math, we call this an if and only if, which is really fancy, and mathematicians love it. It means you can go either way. You can go from knowing the sides to knowing the angles, or you can work backwards from knowing the angles and go back to knowing the sides. And that's what we know about isosceles triangles. Okay. Now think about this. If it's an equilateral triangle, if all three sides are the same, what's that going to mean for the angles? Okay, if all three sides are the same, then all three angles have to be the same. So in an isosceles, two sides that match, two angles that match. In an equilateral, you have three sides that match, so you have three angles that match. So it's kind of even fancier than an isosceles. Okay, so let's take another look at an isosceles triangle. Okay, I want to label up the parts here because I want to stress again that saying base and base angles don't necessarily mean the bottom, the part that it's kind of sitting on. It has nothing to do with how the triangle sits on the page. When we talk in a triangle, when we're talking about a triangle and we talk about the legs, we're talking about the sides that match. So since this side and this side match, this side is a leg and this side is a leg. And in a minute, when we do some practice problems, I'm going to ask you to identify the legs. Okay. So if these are the legs, then that makes this third side the base. The fact that the base is coming down the right-hand side means absolutely nothing. The base is the side that isn't a leg. Okay, so if I want to find these all-important base angles, you have two ways to think about it. You can say, okay, well, here's my base. So it's going to be the angles at either end of the base. So here's one, and here's one. The other way you can think of it is, it's the angles that are across from the legs, right? So if this side and this side are congruent, I'm looking for the two angles that are across from them. I'm looking for their partners in angles. So here's this side. If I shoot across the triangle, there's that angle. And here's this side. If I shoot across the triangle, there's that. If you're having trouble kind of making your way across the triangle to find the opposite side, literally just think of your base angles, base angle, as the angles that touch your base. So if you can mark which side is your base, then the two angles there are going to be your base angles. They're going to be congruent. If you're labeling a base, it's because you have an isosceles triangle. And if you have an isosceles triangle, those angles are congruent. Okay, so let's do a couple problems. All right, so in number one here, notice they give us a triangle. They label isosceles. So as soon as I see these tick marks, this is a leg, this is a leg. And if these are my legs, then this side here that hasn't been labeled is my base. Okay, so if I know where my base is, then I know where my base angles are. So if this is my base, the base angles are the two angles that touch it. All right, so we need two theorems or two pieces of information. Okay. We need two pieces of information to solve this problem. What they want to know here is the measure of this angle and the measure of this angle. So they gave us one, they want to know the other two. All right. So two really important things we need to know to get this job done. The first is our new information, that the base angles have to be the same. So if the two sides are the same, then the two base angles have to be the same. They gave me one of them. They gave me this as 68. Guess what? The other one has to also be 68. It has to match. If these two sides match, then the two angles match. The angles that are across from them, the base angles. That is really not going to write for me, is it? There it is. Okay. All right, now, so that's J, right? 68, fine. It matches the other one. The question is, how am I going to get to this one up here? How am I going to get to the K? And that is going to bring up, geez, man, that is going to bring up another theorem for us. You know, I genuinely hope that someone out there gets entertainment from watching me struggle with my technology, because I do not get entertainment from it. All right, so here we go. Look, we know these base angles are congruent, so fine, 68. We also know something else. I said it the other day, and I said, I'm sure you talked about this in middle school, but I'll say it again. Every triangle ever has three angles, right? And those angles have to add up to one magic number. That is 180 degrees. We know that. There's 180 degrees in a triangle. There's 180 degrees in a triangle. So if I know two of the angles, darn it, I know the other one. Okay? All I have to do is get to the right slide and do a little bit of arithmetic. Okay. So I've got 68 and 68 here. 68 plus 68 is 136. I used my calculator, that's right. Don't shame me. I'm on the wrong slide. No, not. Okay. 68 and 68 is 136, right? Okay. So whatever's left of the 180 has to be what's up here. So all I have to do to figure out this angle is do 180 and take away the 136, right? So I'm going to borrow 1 because I'm into this. All right, so that's 4. So I get 44, and I cross my fingers that I didn't make any silly mistakes. So I think that angle up top there is 44 degrees. Okay, so again, let's talk this again because we're about to do another one. If you know that two sides are the same, then you know those base angles are the same. If they give you one, you immediately know the other one. And then you know that there's only 180 degrees, so you can figure out what's left for the last one. Okay, let's take a look at another one. Of course, they had to throw a wrench in the works here. So in this one, here's a leg and here's a leg. Okay, so I'm going to label it leg, leg, which means this third side is my base over here. So in the last one, the base was on the bottom. On this one, the base is kind of on the right at a slant, at an angle, whatever. Okay, so if this is my base, then these two angles here are my base angles. And I know one thing, and that's that those two are the same. Okay, so if only I knew one, I would know the other. But I don't know one, do I? They didn't give me one. They only gave me this one at the top. They only gave me the angle that isn't the base angle. But that's okay, because I can still get at it. We're going to work backwards this time a little bit. I know I have 180 degrees in this triangle. That's all there is. I got 180 degrees, right? So I can do 180 and say, well, let's see what's left. 180 minus 106, that leaves me with 74 degrees. There's only 74 degrees left. And it's divided in some way between these base angles. Okay, so if it was any other kind of triangle, I would say, well, I don't know. Maybe one's 70 degrees and the other one's 4 degrees. Maybe one's 60 and the other one's 14. Maybe one is 30 and the other one's 44. I don't know. How is that 74 divided up? It's anybody's guess, right? Not this time. In an isosceles triangle, we don't have to guess. I know exactly how the 74 is divided up. It's divided exactly in half, right? These angles have to be the same. So this 74 degrees, I don't have a choice. I have to divide it evenly between these two, right? So let's see. Half of 70 is 35, 36, 37. So these must be 37 degrees and 37 degrees. You have to take this 74 and divide it in half. You have to divide it evenly between these because we know for a fact that they're the same. So we know there's only 74 degrees left to be had after this angle. Got to divide it evenly so my base angles are the same. So over here we can say we know what both of those are. They're 37 and 37. Easy peasy lemon squeezy. All right, you ready to do one more? I am. All right. Ooh. Threw another one at us. Okay, so this one we talked about earlier. Notice they didn't mark any sides congruent. My first thought was, let me go label these legs. Let me write leg, leg, base. They didn't give me any tick marks. However, they did give me these two angles. Allow me to get my highlighter. Looky here. A 77 and a 77. This is what we were talking about before with the whole Converse thing, right? Listen, if I know the sides are the same, I know the angles are the same. I'm working it backwards. This time I know the angles are the same, so I'm going to say, okay, well then, those two sides must be the same. Not the side these angles are touching. That's going to be our base. The two sides up here. The sides that are opposite those angles, across from those angles. All right, so I know these two sides are the same, so I already got one question answered here. I know what YZ is. That's this side, right? Well, if this is 12, bingo, bango, YZ has to be 12 as well. Yeah. All right, so as far as this other angle, angle Y, we don't even need any special theorems here. We don't even need any magic here. We have our fact that there's 180 degrees in a triangle, so all we have to do if we want to figure out what this angle is figure out what's left out of that 180 degrees. Okay, so I started with 180 degrees. I took away 77 for each one of these angles. So 180 minus 77 leaves us with what? 103. And then take away 77 again. And you end up with 96. 26? The other way to think of it is to say, okay, I'm going to take 77 and add those together, the two 77s. So that would be 154. And then say, okay, there's 154 taken up. Let's see what's left for that top angle out of 180. So 6 and 2. And I was right. I did my arithmetic. 26 degrees. Okay? Pay close attention to these questions. Remember, if it's two letters, they're asking you about the length of the side. If they're asking you about an angle, it's always going to have the little angle in front of it. Okay, so I would like you to go into Schoology. There are 4 questions like this in Schoology. Again, some of them they give you the sides, you have to get the angles. Some of them they give you the angles, you have to get the sides. It's a little bit of each. Okay, 4 questions in Schoology. Make sure you finish those off, and we will see you tomorrow.